Okay guys, so this is the design that I settled on. So you'll notice that I changed a few things around. Basically just made it a bit simpler, got rid of a few things, and I'll just quickly take you through some of the changes. So if we just jump back to the scene view, this is our scene now. You'll notice that I got rid of our vase. We don't need that anymore. It was just a little too cluttered. I decided to simplify things. So let me just go to zoom up to our table. So you'll notice that I have this null here. And basically when we first set this up, I was just playing around with some things, trying some ideas. I just wanted to show you guys, what's possible, how to work with different objects, and how to apply materials in different ways. And ultimately, when I started cleaning everything up, this just got a little messy, and I wanted to move all of these objects backwards. So I just hooked it up to a null here and basically just moved it in Z space. But if I was just making this from the get-go, I wouldn't necessarily have made all of these in different objects. Depending on your scene, sometimes it is nice to have it in different objects so that you can just drag and drop your materials while you're rendering them and not have to worry too much about going into the object and adjusting the material here. Sometimes it is nice to just drag and drop. So depending on how simple your scene is, you might want to just create objects in their own object folder. So what I did was I actually just rebuilt all of this so we can hide that. And I'm going to enable geometry all here. So now we have all of our geometry in one geometry folder, one geometry node. And I'll just quickly give you a recap on what I did. And you'll notice that if I just get rid of this transform, everything jumps back to the origin. And it is nice when you are building objects to build it from the origin so that you can get equal distances and stuff around what you're making. So to quickly just go through this, it's basically exactly the same. For our sphere or for our table, we just had the sphere, and then we started with this platonic solid. We transformed it, and then I edited it, just like you saw before. We moved some points around, but you'll notice that we just started getting some weird edges, just because there's a point here and a point here in the middle. So this polygon actually has 5 sides, so you will get a little bit of creasing and stuff in the middle. So what I did was I just deleted the bottom, and then I started deleting a whole bunch of points that were not necessary. And then I just threw a fuse node down. A fuse just takes, if you are merging two objects together, a fuse will take the points over here, and sometimes the points will be really close together, but they won't actually be connecting. And a fuse node just makes sure that all of the points within a certain distance are snapping together. Then we took a polywire node, and we just deleted the UV so we didn't get any errors down here, and then we grouped it with the wire and the table. These get merged, and then merged with our sphere, which is up top here. And then we just did a couple of transforms, made sure that it had decent normals, and then we apply our material down here. So that's our little table and sphere. Moving across, we have our cake stand. So I just started with a circle. Circle over here, just like that. Let me get rid of our points. Let me get rid of this lighting. Okay. Anyway, we started with a circle. It's got a lot of divisions, that's why it's doing this. Then we poly-extruded them, and poly-extruded this one, so we have a big one and a small one. And then we just transformed the one up and added it on top. And remember, when we first did this, I object merged our vase in here so that it would sit on top. And we got rid of that, but I kept this here because you use an object merge to bring objects in from different object groups over here. But if you're wanting to bring in an object from a file directory, then you need to hit Tab and type File. Just add the file sup, and then just click here, and then you can navigate to wherever your OBJs are and import them that way. We're not going to do that, so I'm going to delete all of these because we don't need that anymore. Cool, so we have our cake stand, and I think we had a bevel on the edge. I just got rid of that because what I wanted to do was I just took our original 2 circles again. I polywired them. I just transformed them a little bit. And let's just see. So I transformed it, but you'll notice this expression over here. I'm just taking the expression from this transform and saying whatever this value is, transform our wire the same distance. Actually, I took that from the poly extrude. So this expression is being linked to the poly extrude over here. So whatever the distance is, it will be transformed up. And then we moved our transform over here. And I just copy pasted the same transform. But if you want to do the same, you can just right click over here, say copy parameter, and then where this transform is, say paste relative references. And now whenever we change this, our wire will move along with it as well. Cool. And then I deleted the UVs again, just so that we didn't get any errors. We grouped them. I'm going to get rid of this transform. Then we just gave it some normals, and then our materials again. Cool. And then moving on to our tube. So I'm going to start over here. We took a tube. We poly extruded it a little bit. Remember to give it back faces. Output back, so we get a full piece of geometry. Deleted the UVs, and then just grouped it again. And then instead of beveling these edges, I created the same rings around it again. So I took a circle and made it the same size as our tube. And see, I copied the radius scale of our tube, and I pasted the relative reference here, so that whatever the size our tube is, our circle becomes the same size. Then I just transformed and polywired it, and then transformed it again. So yeah, I transform it again, so we get 2 on either side, and then I duplicated it so that we get the same rings on the inside, and then same thing again, just through a group. And then we merge those together. So now we have our tube and we have our rings around the edges. Then moving over here, we just took another circle with a polywire on it. We used the copy and transform sup. We just gave it 12 copies and rotated each increment by 5 degrees. So we get this shape. And then same thing, grouped it, delete the UVs, and then we merge it together. So now we have that. Cool, and then lastly, I just took a circle. If we enable our points here, we can see our points. And then what I did was I just took a point jitter so that we can randomize the position of this, or just jitter the points. Then I created the attribute called p-scale. I essentially just initialized it because the points do have p-scale, but you just have to throw down an attribute create, throw in p-scale, make it a local variable. And then what we did was we just randomized the p-scale. So going into the copy stamp, we just took a little sphere down at the origin there, and then we are copying this sphere to each of these points and the spheres change size because we randomized the p-scale or point scale. Same thing, deleted the UVs, grouped them, and then we merged them down here. So now we have this, and then we just transform it downwards because we want to add our fixture to the top. So what we did was we just took a line. This has 2 points. We polywired it so that this is our essentially what the tube is going to be hanging from. We took a circle, we poly-extruded it so that we get a little base like that, and then we copied it to these 2 points. So again, if we update the line and if we say 4 points, it's going to copy this shape here to however many points are on this line. So we do that. I'm just going to set it back to 2. Then we merge everything together so that we have this this fixture with a top and an end cap. And again, if we go to our line and we make this 3 now, everything is going to move along with it. So a little bit of proceduralism. And let's just take that down to 2 again. And then we just transformed it a little bit. We deleted the UVs, we grouped it, and then we merge it back in. So now we have this shape. And what we do then is just transform it up so that it looks like it's hanging from the ceiling. Gave it some normals, materials again, and then we merge everything down at the bottom. So now we have this. And keep in mind that I just left the materials where they were for the sake of it. But what you could do is actually just have one material node and take it all the way down to the bottom of your object. If I middle mouse over here, you'll see that we have 9 primitive groups, and those will show up underneath here if we had to throw a material node down. And then I just transformed it back in space to where our other objects were, and that's about it. So now you guys should have a decent understanding of how to build some simple objects inside of Houdini, and you know a few different ways on how to do it now. So depending on how much time you have, sometimes being quick and dirty is better, or it's just faster. But for the sake of this tutorial, I just wanted to cover as many bases as I could. Cool. So those are our objects. So just to go over the other objects, we have our floor over here, which is just a grid. I gave it some normals. We have our wall, which is the same grid, which is just transformed backwards, and we set the grid to be on the XY plane as opposed to the ground plane, just like that. And then our arch, what we did was we just took a tube, transformed it a bit. We got rid of the faces that we do not need. We poly-extruded it, and then I was getting a few errors, so for as a fail-safe, I used the convert node, and it's just converting it to polygons. So it's saying whatever is above here, just convert it to polygons, and I just wanted to make sure that Mantra was reading this as a polygon. Then we gave it some normals, we gave it a group, and then I added just a little detail where I did the same thing. I took a circle, we transformed it the same as this transform, and then I transformed this twice and merged it together so that we get front and back, and then I just polywired that, gave it some normals, and we grouped it, and then we go down to a merge so that we merge it with our archway, and we get our little wires on the edge. And then I just transformed it a tiny bit downwards, and then we give it our material. Cool. So that is essentially the final scene that I got to. I'll be making the HIP file downloadable if you want to jump inside and see exactly what I did. So you guys can grab that if you want to browse around. Just going over everything, we have our camera that we set up. And if we come up here and go to Cam 1, there's our camera. And then we have our environment light, which should be the same. I did play around with a bunch of different environment lights, and I actually settled on what we had originally set up. And it is using Studio Small 5, 2K DSAT blur. Just download the HIP file. This will be in there as well. And don't forget to check out hdrihaven.com. Some awesome stuff on there. And then what I did was I added an area light. And essentially they are like the only lights that you really need are environment lights and area lights. You can do a lot with an area light. And just to show you guys that I just needed a little bit more light coming from the end here. So I just created I just command clicked on an area light, and that will, it will do the same thing as a camera. It will snap you to the area light. So then you can hit the lock button and move that area light around. And when you like where it is, just uncheck the lock, and now you can move out of it. And there is our little area light that we just created. So you'll notice like the exposure goes pretty crazy. Usually I just get rid of that, and then we can dial in the intensity when we render. One thing to note is that normalize light intensity to area is always checked. I don't like using this. Basically what it's saying is that if our area light is say 5 by 5, it's going to multiply the intensity of our light by 5. So basically the bigger the light gets, the more the brighter it gets. And I don't like doing that because I like making different shapes of lights, especially really long ones like this. And so I uncheck that just so that you can dial in the intensity here without having to worry about multiplication and things going crazy. So, you know, I just made something like a light something like this, and let's see, we have our exposure pumped up quite a bit, and you'll see that I changed the size. You can also do, let me just go to the light that just popped up. So the light that we just created, an area light, you can change the type from grid to say disk, and it will give you a circular shape, which might be better for your reflections. It will actually show up as a circle as opposed to a square grid. So it's usually grid and disk. And then the only other things that you really need to know, or that I use, is a sun. So the sun, if you change this light into a sun, you'll see that it updated now. And essentially, it's mimicking a sunlight. So it doesn't matter too much about where this light is. It matters more about which direction it's pointing. And you have to go over to spotlight options here. Distant light options, and change some settings. So the sun angle is essentially just diffusing your shadows. So if you, I believe if you have a sun angle of say 1, you're going to get really hard shadows, and if you have a sun angle of say 45, it's going to be a more diffused, softer shadow. And basically there's sun and then there's distant. The only difference with the distant light is that it doesn't give you the sun angle. So that's why I say usually, you know, just change it from a grid to a disk if you want different reflections, or just use the sun because you get the sun angle and you are able to diffuse your shadows. So that in a nutshell is the area light. Usually when I create a sunlight, I will just zero out the values here so that we get it at the origin. Let's just select that, spacebar F. And then what I would do is I would say rotate it 90 degrees. Just move it up in Y by say 10. Let's just do 5 for now. So now we have the sunlight which is pointing directly downwards. So it should just come from infinite and point downwards. And then what I usually like to do is, like I did with the objects, you just throw down a null, plug it in, and now you can rotate the sunlight around the origin and just basically focus on rotation. So you don't have to worry about where it really is. Right now we're just rotating our light from a top light over to the side, and we can just control the sunlight like that, essentially. I find it a lot easier just to play with some values and dial that in. So essentially that is an area light, and yeah, it's pretty straightforward. Cool, so we have our lights, we have our camera, we have our objects that we created. Now let's go and have a look at our render settings. So just gonna go to cam 1, and let's go over to our render view. So this is essentially the look that I got to. I created a few more materials, stripped away a few things, and just added some simple noise, as you can see here, just to break things up, just to give it a little bit of texture, just to make things a little bit more interesting, make it interact with the light a little bit differently, and it really adds some complexity to your scene. As you'll notice from before, we went from quite white, and now we have a bunch of visually interesting and appealing materials. So let me just go through that quickly with you. So this is the original material that we created. I'm just going to get rid of our parameters by hitting P. So here, this is what I took you guys through earlier. A sequence of noises and multiplies, fit ranges, in order to create our copper procedural, our procedural copper material. So then just up at the top, what I did was, so for our back wall over here, I basically just took the global variables, threw down a rest position, I threw down a turbulent noise, with just, I really didn't change much. I just changed the frequency. I threw down a fit range and just clamped some of the values so we get a bit more contrast. And then what I'm doing is I'm just adding default white, because this color over here, I could have used the fit range, but I can also add a little bit of color now if I want to do this. But essentially all I did was just boosted it up a little bit. I boosted the blacks up. And then I just took a multiply constant and gained it down a little bit because it was getting a little bit bright. And then that just plugs into our base color. We've got a pretty rough material. I threw a little bit of metallic in there as well, just to get a bit of a shine and a sheen on it. And that is for our wall. So, I mean, you can even see with just such a simple little setup, we get quite a lot of nice detail, and we get to break up our back wall with a little bit of noise. And then the same thing goes for the floor. This one got a little bit more complicated because I wasn't getting the reflection off of the floor how I wanted it to. I wanted to get a little bit of shininess, so you can see over here we start to get a little bit of reflection, and that is all of this. So essentially, again, for the base color, I think I just copied the same as our wall over there. So it's the same material, it's just getting hit with light a bit more intensely because of the angle, and I'm not multiplying it. And then I took another turbulent noise. Let's see what we're doing there. So it's just got 5, 5, and 20. So we're getting some streaks. I gave it a fit range. And then I threw another one down with just default 5, 5, 5. Another fit range. And then I'm adding those two together. And then I took a few more turbulent noises, somewhat medium frequency, a lower frequency with some stripes, and then a little bit of a high frequency. Fit ranged it. And then for this one, I took a fit range so that we get a bit more contrast. And then I'm subtracting it. I found instead of multiplying it, I was getting the values in the wrong place. So instead of multiplying, I just subtracted it, which essentially does the opposite of a multiply. It subtracts exactly what it says. And then with these two, I multiplied them together, and then I used the multiply constant to gain it up. I basically multiplied it by 2. And then I mixed it together. So this is another good node, because adding and multiplying and subtracting don't give you parameters to adjust the bias and how much you want one to influence. You can throw down a fit range and do it that way, but sometimes it's nice just to use a mix. And I'm mixing input 1 and input 2, and then for the bias I am saying lean closer to input 1. And, or it actually might be input 2. So just play around with this. And then that is being plugged into the roughness. So we get a little bit of shine, some broken up reflections over here. And then for our wall, this black wall over here, this one also took me a little bit of time to really dial in. And essentially what we're doing, again, global position, rest position. I'm taking a turbulent noise, I am fitting it, and that's doing nothing. And then what I'm doing is I am distorting the position that these two noises are getting plugged into. So basically it just distorts it, and I get a little bit more fractal kind of detail. So then I took a turbulent noise, default 555, fit ranged, and then I took another turbulent noise with the lower frequency, and I am multiplying those two together. Then I am fitting it, which was giving me this this nice pattern, but it was reversed. So what I wanted was, it used to be where it's black, it was white, and where it's white, it's black. And I wanted it the other way around, so I took a negate. And essentially what that does is negates the values. So you just got to be careful, because with a negate, if you have any negative values, or actually, so if you have any values which are going a little crazy, like going over 1 or under 0, it will actually flip it and you'll start to get negative values, which is not what you want necessarily. But I was struggling to actually get this richness of black in here. So I took a clamp, and I'm actually clamping it to negative 0.02. So I am getting negative values, but I'm going to fix that in post, which is fine for now. So usually, like if you throw down a negate and it's not doing what you wanted or giving you some crazy values, usually what I would do is throw down a fit range, plug it in, and then I would just flip these values. So instead of 0, I would put 1, and instead of 1, I would put 0, and that basically reverses it, but it keeps the values between 0 and 1. So just one thing to keep in mind. And then I took another fit range, and I kept it at negative 0.02 because the fit range clamps everything. So I just kept the same minimums, and then I am gaining up the max. So I'm getting more deeper blacks here. And then I am just taking 0, and I am adding to that. So technically this shouldn't actually be doing anything. And then that just goes into the base color. got a little bit of a metallic sheen on that. The roughness is set to 1 because I didn't want I didn't want too much. I didn't want a reflection or like a hot ping on here. And that is our material over here. And then basically what I did was I just took our procedural copper material that we created, and for these little spheres and also for our rings over here, they're such small objects that I don't really need displacement on that. So what I did was I just duplicated the setup and I disconnected the displacement. You can hold down Y and just cut any wire like that, click and drag, and it disconnects it. So those are the materials that we are using for this final scene, and here are some of the other ones, just the basic ones that we had created when we first starting off, and that's it for the materials. So with these materials, you know that we added them to our objects via a material node, or just dragging these onto our objects, as long as it's just a single object, or if you want the material to be applied to the object on a whole. Cool. So then with the lighting, our environment light and the little area light that I added, let's now take a look at the render settings. So now that we have our scene, we have applied our materials, we've played with the lighting a little bit, let's go and check out the render options. So if you haven't done so already, to create a Mantra render node, you would come up to the top here, click on render, and go to create render node, and I choose Mantra PBR, or physically based renderer. And that gets dropped down over here in our out context. And cool. So I'm just going to jump back to this one where I used some lower settings because render time gets a little crazy. But I will show you all I do, all you really need to do. You know, there are a bunch of tabs over here, but I will just, I'll take you through everything and show you what we do. So when we first threw this down to test some of our lighting and just get a general idea of how our scene is going to be lit, this was set to 333. Let me just get some space here. And in our limits, this was set to 10, 10, and 1. So, and then this was set to use black background. So this is how it would be when you first started up. You'll see here we have physically based rendering, or ray tracing is another option that people use. I just use physically based rendering. Cool, so our pixel samples here, what this is saying is, let me just change this to 4, 4, and 4. Or 4, 4. So essentially what it's saying is that each pixel of our object is going to be divided into 4, and that's how many times each pixel is going to be sampled. So for each pixel, it's going to be sampled 4 times. So this is relating to our direct samples, and below here we have our indirect samples. So you'll see at the moment it is set to 45. If I change this to say 30, you'll see we now have 150 samples. So now if I start pulling these down, let me just take away the diffuse, subsurface, reflection, refraction, and volume. And you'll notice that we have 30 samples. So because we have set our max ray samples to 30, it means that globally we are going to have 30 samples. Let me see. Yeah. Okay. So global quality, I don't touch, don't worry about that. So now as we start to increase these, you'll see we get 60 because our diffuse is now being sampled from the indirect light. If we change that to 1, you'll see we get 90, and the same with all of them. So right now, each of our render layers is going to have 30 max samples that our lights are going to cast. So I used to use this a little bit differently. I used to just keep it at, say, 9, and then, I mean, you can still do this, but 9 is quite a low number. And essentially, if you'll see that we have 45 now, these are multipliers. So if we have a look at, say, let's go to indirect reflection, you'll see that we have a lot of noise in here. So if I had to, say, pump this up to 4, you'll see that our indirect samples change. So now instead of 9 samples for the reflections, we are now going to get 28. So let me just change that to 10 so that we have equal. So now you can see that the reflection is going to get 10 samples, but then we are multiplying that just for the reflection only. So if you notice that, if you're maxing kind of out your settings and you're still not getting the quality that you need, you can just pump this up even higher. I mean, I wouldn't go that high, but just keep in mind that these are multipliers. So what I'm going to show you now is what the only things that you really need to change here for simple scenes like this is our max ray samples. So it will be set to 9. If you bump it up to, say, 30, it should be more than enough. Obviously, for final render settings, what I'm going to do is actually give it 30 indirect samples, and then our pixel samples, usually 7 should be enough, but sometimes I just like to make sure that I'm getting a nice clean render, especially if it's going to be rendering overnight. I can let it go for a little bit longer. So I'm going to be rendering this for the final at, say, 8 and 8 pixel samples and with 30 max indirect samples. So the only thing we need to talk about now is the noise level. This is quite important, and I will tell you why. So basically now, right now, for each individual layer, our lights are going to be casting rays. It's going to be shooting rays from the light source at our object. Now, it is going to keep shooting rays to a maximum of 30 rays or 30 samples. It's going to sample our image maximum 30 times. But if it reaches a calculation of a noise level that is 0.01, it's going to stop casting its rays. So what that means is if you pump your max ray samples and you still have noise and flickering, it means that, say we take this up to, say, 50. Now we have 250 samples, but it's going to sample the image 250 times or shoot 250 rays until it reaches a noise level of 0.01. So if you are still getting noise, it means that it might reach this noise level at, say, 30. So once it detects that there's only this amount of noise left, it's going to stop casting its rays. So that's why you might be like oversampling different areas if you keep pumping this up, and you're still getting noise because it's cutting off, because this is essentially a threshold. So what you would need to do, and be very careful with these values, what I would do is, say, maybe change it down to 0.05, and that should be more than enough. So now it means is that it's only going to stop casting rays once it reaches a noise level that it can detect of 0.005, or if it hits its max ray samples. So that's a little bit, that's quite a lot to kind of take in and gauge. If you are new to Houdini, I wouldn't even worry about this. Don't worry about the noise level unless you're rendering animations. For your final renders, pixel samples of 8, 8, and max ray samples of 30 should be more than enough. So really all you need to do is adjust your pixel samples. Keep it low for when you're just testing things out. I'd say 7 is really good. And 8 is nice quality. Don't touch the min samples, just the max ray samples, and you don't really need to worry about this. So let's just go back to our image. And this image was rendered with pixel samples of 3 and 3, so don't worry too much about the noise. If you pump this up to 8 and 8, we will get a nice clean render. So that's sampling. Our limits, like I said, that this is just limiting how many bounces it has. So our reflection, I usually just set this down to 3 and 3. Refraction is a little bit different. Think about it like this. Our sphere here, if this was a glass object, light has to enter it, so it hits this side. So that's one bounce. It goes through, and then to come out, it bounces again. So say we had a vase, like a cup. Let me just show you here quick with our vase. So if I enable this guy again, so basically, because we have given this an edge, so because we have given this an edge, you'll notice that there is one side here, then there's another side, and then on the other side there's this edge, and then it has to move through and be able to bounce out of the object if this was glass. So that means we need to have 1 to hit the surface, 2 to go through into the object, 3 to bounce to the other side of the object, and then 4 bounces to eventually exit the object. So that is essentially what our limits are. So right now, if we have a refraction limit of 3, it means it's going to enter the surface, bounce through the object and to the inside, and then once it hits this edge over here, it's going to stop. We would need to change this to 4 so that it will be able to successfully bounce out of our object and escape again. And that's why you'll notice that there's this @ray limit. And right now, if we had this at 3, we would probably get a black refractive artifact in here. Somewhere in here, light is going to stop bouncing, and because there's no more bounces, it's just going to go to black. And that's why it's handy, like if you had, say, 50 of these vases next to each other, the amount of bounces that you're going to need to go in and out of each object is just going to be ridiculous. So if you just go, instead of use black background, use direct lighting, it means that wherever we get black artifacts, it's going to swap it out for our HDRI reflection. So it's usually a good idea to check that on. I usually don't go any higher than 4 and 4 with these. You don't rarely need to. And then our diffuse limit is global illumination. So like I showed you before, we need this in order for our objects to be able to cast color and basically get some diffuse color bouncing around. And I did enable it for these renders. And it's more physically accurate. Without a diffuse bounce, you know, your shadows will be darker. It will technically be less physically accurate because ultimately light does bounce off of the diffuse and the color of things in real life. So usually you will get a more accurate and a better looking result if you have the diffuse limit enabled, which is global illumination. And yeah, but when testing things out, this does add a lot of render time. So when you're testing, just go to 0. And then when you do a render, just take a snap and then enable the diffuse limit again, and then just compare the two, because usually this one will look better. And then if you have any subsurface scattering in any of these objects, you need to turn the limit on, otherwise subsurface scattering will not be calculated. The same goes for a volume. If you have a volume in your scene, if these are not activated, if they are on 0, you will not be able to see the subsurface or the volume. And then just going over here, don't worry about the shading tab. Coming over to render, this will default to 16. And essentially what this does is when you render, at least for a final render without these checked, it's essentially the tile size. So it will create a tile size which is 16 by 16 pixels. And I believe that, at least for me, when I'm rendering, it will be CPU based. So I can actually maximize my rendering capabilities. I have 24 cores, so I can change that to 24. And it will give me a bigger area size and essentially maximize the amount of size each CPU is calculating. I actually will probably double this and hyperthread it. So, well, not hyperthreading it, but you're basically just saying, you know, instead of 16 pixels, just render 48 pixels by 48 pixels. And it goes a little quicker depending on your scene. So I will usually bump up this tile size. And that's about it for here. Have our samples, have our limits, we've set our tile size. That's all cool. Then let's just go over to images quick. And where it says extra image planes, this is where you would be able to get your render layers out, like I did with this image. So you can see up here we have our indirect diffuse, we have direct diffuse, we have our indirect reflection, direct reflection, and there's nothing in the coat or the refraction or the volume because there aren't any materials with those in our scene. So we don't need to worry about that. But if I just come back up to C, I got those. You see export components, it says diffuse, reflect, coat, refract, volume, subsurface. If you just check direct lighting per component and indirect lighting per component, it is going to give you all of these layers for compositing purposes afterwards. And then we also have our depth. So PZ is just position of the Z depth. And we have this, which is our depth pass. And I got that by checking the shading option. And just remember, as a reminder, for the depth, you need to make sure that you set it, set the right distance via the camera. And you do that by coming into the view option here. And with this transform control selected, you'll notice that we get this blue handle that shoots out of our camera, and it goes here. Let me just spacebar home. Spacebar H, and you'll notice that I have dragged the other side of our handle here to where I want the focal point to be, where I want the focus to be. So right now it is on our sphere, and that's why when we go to our render layer, this is essentially what will be in focus. And then just remember in the sampling tab, there's f-stop, which will control how much depth of field that you actually get if you are rendering depth of field. Usually I enable the depth channel because it's quicker to calculate this way, and you get a much better result when you apply the defocus in post in, say, After Effects or in Nuke. In order to actually render depth of field in the viewport in our render, you just need to enable enable depth of field. And now when we render our image, our background will be defocused, and basically whatever we have set to be our point in focus will be in focus. And then to control the amount of defocus, you would just bring your f-stop down. So 5.6 is pretty average. If you want a lot of depth of field, go down to like 1.2 or something. And depending on your scale, you might need to go to like 0.1 or something like that. It all depends on the scale that you're working. But in terms of cameras, this should be quite a lot of defocus, 1.2. So I'm just going to reset that to 5.6. Cool, that's depth. Then let's see what else I got. So here are your normals. This is your position pass. You can do combined lighting per component. So if you check that, it's going to give you light selects. So basically it's going to render out everything, but it's going to give you all of the layers that are being lit by the environment light, and then all of the layers that are being lit by the area light, which we created. So you would be able to add all of these layers back together for your area light and for your environment light, and then if you plus them all together, you'll get the original image. So the last thing that I did was, here's your combined emission. So if you do have emission in your scene, remember to check combined emission. And then what I did was I enabled direct ray samples and indirect ray samples. So you'll notice where we go rendering, we talk about direct ray samples, and these are our indirect ray samples. And you'll notice that if I come up here and go direct samples, now we have an idea of how much sampling or how many samples are hitting our scene. So you see here that it's looking pretty blocky and pretty chunky. There's a big black area here, and because it was rendered with such low samples, we can see that we don't have enough samples to get a nice looking image. And the same thing is that if we go to indirect samples, we have this, so we can see that it's quite blotchy, it's not looking very good, and a lot of your noise is mainly going to be coming from your indirect samples. So that's why we pump up our samples over here to 30, and this is all you really need to adjust. Just one thing is that Side Effects does have a great document which really goes through all of this in detail. I will add a link to that, because when I was first starting out, I read through that, and it gives you a better understanding of how Mantra is calculating things. But essentially what I showed you just here will get you 95% of the way there. And for still images, we don't really need to worry too much about noise. These settings should give you a very nice looking image. So back to the images here. So say we're good with that. Use the direct and indirect ray samples just as a guide. They're not really used for anything other than seeing how many samples you are getting. So if you have any problem areas, this will tell you where those problems are. And then also obviously looking through, so say if we go to our indirect reflection, you'll see that we have a lot of noise here. I can either pump up this, and again, this was rendered at 3 and 3, so really not a lot of samples. But say we were still getting some noise in our indirect reflection, I could then just pump our reflection quality to 2, and now it's just multiplying the amount of rays that are being cast in our indirect reflection layer. So that's all that does. And yeah, lastly, for under images, when you are rendering out an animation, there's output picture here. And basically what I do is I copy this, or I at least copy this end, because it's got a bunch of render tokens here. So if you just hit Command C, Control C, copy that, and then it looks like it's already going, okay, it's not in the right place. It's going to the $hip. What we want is now the $job, and we go into our render. Usually I would create a new folder, say like anim1, and then now that we're inside there, I would just copy and paste this. So what these tokens mean is that it is going to take the name of our file, which is currently Houdini Everyday 01 version 3. It is going to give you something else. I have no idea what that is. And then it will just give our frames. So right now it is going to sequence it. So 1 is going to have 4 units, so it will be 0, 0, 0, 1, and then increment upwards from there. So that's just for animation. I usually just keep it the same and just change the directory. And when you render an animation, you have to come up here and click Render to Disk. And when you click that, then it is going to, currently it's going to render the current frame, but we would need to change this to render frame range. And if we had any animation, once you hit Render to Disk, it's going to render frame 1, 2, 3, 4, all the way to 24, or however long your timeline is. but we'll just keep that at render current frame. And then if I just switch over here and go back to our color. So say this was our final image, I wanted to render it. I like seeing and being able to check up on how far along the render is, so I usually just render it from here. And then when I'm done with it, I would just right click, go save frame, and then I would make sure that we are in our directory. So right now it's $job img, and then I would just say Houdini Everyday 01, version 1. Usually I would save it as an EXR. Just leave all of the defaults, click save, and image has been successfully written. And then I would just save frame again, and then we can render out a JPEG. So the EXR is going to have all of your render layers in it. So your indirect reflection, your direct reflection, diffuse, etc. You can only save those by saving an EXR because JPEGs are not able to store multiple layers in them. So if I want to edit it, I will render out an EXR. If it's not necessary, I will just render out a JPEG. So if we click save, it has been written. And then if we go over to the right here, we can see that in our images folder, so we have our image here as an EXR, and then we have it as a JPEG as well. But because I changed a few things on here, so if we go over here and just right click and say save frame, save it as a JPEG, just say version 2, hit save. We now have our render here, which is a JPEG. So that is essentially rendering. This is how to use the Mantra PBR node. This is all you should really need for right now, especially if you're just starting off. These are the parameters that I change, and hopefully this tutorial series has helped you understand Houdini a little bit better, help make it less intimidating, and just give you guys a basic outline on how to move in and out of Houdini, going from a blank scene to a rendered image. We just kept it really simple today, really minimal, but this is everything that you guys should know in order to create something that looks like this. And I hope you guys have enjoyed the series. So that's all for now. Enjoy, and we will see you again soon.